Well, in three dimensions, we can have the equivalent to what we've looked at in one and or an extension really of what we looked at in one dimension and two dimension, and that's the full quantum mechanical particle in a three-dimensional box. And the extension is really straightforward. Now we have three dimensions, x, y, and z. The potential is zero everywhere inside the box, and it's infinite otherwise. And so now we've got a particle that's rattling around inside this this box. A, B, and C are the sides of the box. I won't go through it, but it should be pretty obvious that the extension is going to look like this by the time you get done. It's probably worthwhile for you to go through this 3D box and follow the pattern that we used with the two-dimension and see if you get these results here. But I would say it's worth going through once to see that you indeed get the formulation that I show you here. What we find is that we have the stationary states, the eigenstates, the eigenfunctions, depend on three quantum numbers, n1, n2, and n3, and it's really turns into by the separation of variable technique like we did in 2D. In 3D, it just extends it to that third dimension. And we get these wave functions. We use the normalization by separating out the normalization in the x, y, z, and t. And we find the corresponding energy levels is labeled by N1, N2, N3, and those are this one here. And then, of course, N1, N2, and N3 can be any combination of positive integers for this. Notice one thing that I didn't point out with, but it occurs in all the one-dimensional, two-dimensional, and three-dimensional. The lowest energy state is not zero. The lowest energy state occurs when these are all ones. So the ground state is the 1, 1, 1 state. Well, as I said, I'm just presenting it. I would encourage you to go through on your own in the remaining time that you have and work through the details on this and see that you get these results here. If it becomes a cube, then A, B, and C are all equal, so a cube of side A. If you look at these, I will get a 2 over A in each term, square rooted, so I'll get a 2 over A 1/2 cubed, or to the 3 halves. And then the A, B, and C here all become A's. Okay? And so a common thing that's studied in lots is the energy levels of a particle in a cubic box. Reduces that. There's lots of degeneracy in it. Okay? And if you start enumerating these energy states, you can take a look and see that the ground state is E11, and it only has one wave function there, so its degeneracy is 1. If I go to 2 here, there's really 3 ways to get the same energy. I can have 2, 1, 1, 1, 2, 1, and 1, 1, 2. And all of those will have the same, for this particle in a cube, will have the same quantity here. I'll get 1 squared plus 1 squared plus 2 squared. So that is 4 plus 1 plus 1, which is 6. So I get 6 times this value for these energies here. And I have 3 different wave functions, all of which can have those energies. And so that energy level is degenerate with a degeneracy of 3. As you go up to higher level states, I'll go just to one more. And, well, maybe I did. I can't remember if I did 2 more. Or, I think I did maybe 2 more. I can do 3, 1, 1 the same way. Its degeneracy is 3. And now then, if I go up to the state 1, 2, 3, well, any combination of 1, 2, 3 and here will give you the same sum. And so I can take 1, 2, 3, 2, 1, 3, have any combination or any ordering of these. Okay? And if you count those, that's 1, 2, 3, 4, 5, 6. I've labeled all of them here. So I have 6 different states, all of which, this should be a psi down here, all of which have exactly the same energy level. All of them have this energy level here. And so the degeneracy of this state, the energy is all the same. I'll have a 1 plus 2 squared, so that's 5, plus 3 squared, which is 9. So this would be, what is that? 5 plus 9 is 14. So I'll get 14 times this. All the same energies, but all of these states here have that energy, and so the degeneracy is 6. So, and as you go up to even higher energy, and this is pretty typical, as you go to higher energy levels, the degeneracy of the states increases as well. And so, because there's lots of different combinations that can give the same energy.